In this video, we'll be looking at some of the solid principles. So solid principles are object-oriented principles for effective software design. So these principles were conceptualized by Robert Martin, popularly known as Uncle Bob, and he is a very prominent figure in software engineering. He is one of the founders of the Agile Manifesto, of the Agile development process. And using these principles, we can make our code easy to understand and modular. And these principles support the concepts of good cohesion and loose coupling as well. So let's look at these principles in detail. Now, SOLID is an acronym. S stands for the single responsibility principle. O stands for open close principle. L stands for Liskov substitution principle. I stands for interface segregation, and D for dependency inversion. Now let's look at each of these principles in detail. Now the first principle is the single responsibility principle. Now as the name suggests, every class should have a single responsibility or purpose, right? So every class in your software system should have only one responsibility in the software system. So let's take an example from the seller portal itself. Let's have a look at this class diagram, which contains only a single class. So the seller class contains information about the seller ID, the name, the address, and about the product. And it has functionalities related to adding a seller, deleting a seller, adding products, right? As well as deleting some items from the inventory, adding items to the inventory, and viewing an inventory. So learners, let's reflect on the design of this class diagram, right? Do you think it is following the single responsibility principle? Can you identify different functionalities which are embedded into the single class? So as you would have noticed, this design, it violates the single responsibility principle, right? The reason being, you have functions and attributes related to the seller, related to the product, and related to the inventory, right? So let's see how we can refactor this code. So refactoring means how can we change this code so that it follows the single responsibility principle. So what we can do is split that big seller class into three different classes, right? The seller class contains details only about the seller and appropriate functionalities related only to the seller, like add seller and delete seller. Then we have a product class which has details regarding the product. And the inventory class takes the seller ID as an attribute and different products gets added to the seller inventory. So in this way, each class has a single responsibility or purpose. So let's look at how we can implement the single responsibility principle in our code. So the code on the left here, it contains a single class called seller, which has attributes and functionalities related to the seller, the product, as well as the inventory, right? And in our main method, we create a single seller object, and that calls all the necessary functions. And here we see that the seller class is actually violating the single responsibility principle. So now the code on the right, we divide or we split the seller class into different classes, right? So we have a seller class which takes attributes related to the seller. We have a product class which takes attributes and functions related to the product. And we have the inventory which takes member functions related only to the inventory. So in this way, we have split a monolithic class into separate classes, and each class performs a single responsibility. And now in the client, we create separate objects for a seller, for a product, and for the inventory. And for each of these objects, we call the appropriate member function. The advantage of this code is that, let's say we wanted to make some change in the product class or with attributes related to the product, right? So in that way, we need not modify any of the code related to the seller or the inventory in a major way, right? And as developers, it is easy to identify mistakes in our code because the code is isolated in terms of different classes and objects. And let's say we have to, if there is an error related to the product class, right? So we need to just look at the product class and modify member functions related to the product class. Now that we have seen the single responsibility principle, let's look at the next principle, which is the open-close principle. So according to the open-close principles, software entities should be open for extension, but it should be closed for modification. So what does this mean? This means that whenever we write code, we should make sure that we are only extending a class's behavior, for example, by creating subclasses, etc., without modifying the existing classes. So let's take an example. So let's say we have a product class, right, which has product attributes like the ID, name, type, and cost. And now let's say I want to add a new product type, for example, clothing. So a clothing product like a shirt will have additional parameters like the size, the color, etc., right? Now one way to add a new product type like clothing is to make changes in the existing product class, right? So I can add size and color attributes, and I can add a new member function called add product, which takes the size and color as well. Now this design actually violates the open-close principle. So in this case, we are modifying the product class by adding attributes to an existing class. So learners, what can be done to this design so that it does not violate the open-close principle? So now let's see how we can implement the open-close principle for this design, right? So what we can do is create another class called clothing, which inherits properties of the product class. So clothing is a subclass of product, and whichever are attributes specific to the clothing class, that can be defined in the clothing class. So the clothing class inherits these attributes like product ID, name, type, cost, as well as it has specialized attributes like size and color. So in this way, we see that our product class is untouched, but we are extending the class by adding a new class called clothing. In this way, our design, it satisfies the open-closed principle. Now let's see how we can implement this principle in our code. So the code on the left, you can see that we have a seller class and we have a product class, and initially we just had the product attributes, and now if I want to add attributes related to clothing, one way which I can do that is make modifications into the existing product class. So I've added two attributes here called size and color, and I create another function called add attribute which takes the size and color. And in my main method, I create a product P1 and I create another product object called shirt1 which calls the appropriate add product function, and it inputs the size and color as well. So this code is actually violating the open close principle because we are modifying an existing class and adding additional attributes. So let's see how we can apply the open close principle to this code. So the code on the right here, we see that the product class does not change, right? But we create an additional class called clothing, which extends the base class product, and we add specialized attributes called size and color. And we create or we extend the add product functionality here, and we include the size and color to this function. So in this way, we see that the existing class is not modified. It is not modified at all, whereas we have extended the functionality for specialized classes. So another advantage is, now let's say if I want to add another product called book, I can do that by following the same principle. So here I have attributes called author and publisher, and I have another member function called add product which takes these attributes. And in the main function, all that I have to do is call or create objects for those specialized products. So here I create a clothing product, clothing object, here I create a book object, right, and call the appropriate methods in those objects. Now that we have seen what the open close principle is, let's look at the next principle, which is the Liskov substitution principle. So the Liskov substitution principle generally works and is applied to inheritance hierarchies, where you have a base class and you have derived classes which extend the functionality of the base class. Now the Liskov substitution principle states that the derived classes, they should be substitutable by their base class. So what this means is that, let's say we have a derived class D, and D is a subtype of a base class, let's say B. And what Liskov substitution principle says is that we should be able to replace methods in the base class with the methods in the derived class without interrupting the behavior of the program. So this might seem a little abstract. So let's take an example. So let's say we want to implement a feature where we want to notify sellers about feedback regarding their product. And we want to notify sellers through email. So here is one possible design which implements this feature. So we have a product class and we have an abstract class known as feedback notification, which has an abstract method called notify, right? And the email notification class extends the feedback notification class, and the notify method here actually implements the feature of notifying sellers about the feedback through email. Now let's say I want to extend this feature and now I want to notify sellers through email as well as SMS. So what we can do is create another class known as SMS notification, which extends feedback notification, right? And we can implement the logic of how sellers will be notified through SMS in the notify method. However, there is a slight issue here, right? So if you've noticed, the third parameter is email, and here instead of email we need to have a mobile number field, right? Since we are going to send an SMS to a particular mobile number and not an email. So here this design is actually violating the Liskov substitution principle, because the method in the base class cannot be substituted by this method in the derived class, right? So learners, let's reflect on this for a moment. What changes should we do in this design so that we can follow the Liskov substitution principle? So what we can do, as we notice that this email field was causing issues, right? So we can remove that field from the abstract class and we can create derived classes and add the necessary parameters there. So for example, we'll have an email notification class which has an additional parameter email. We'll have an SMS notification class which will have an additional parameter mobile number. Both of these classes extend the feedback notification class, and if you look at the method, both can actually implement the abstract method from the base class. So in this case, you can see that the methods in the derived class can be substituted by the methods in the base class in this case. And so this design follows the Liskov substitution principle. Now let's see how we can implement the Liskov substitution principle in our code. So the code on the left is the code before we apply the Liskov substitution principle. So we have a class product and we have an abstract class feedback notification, which has a notify method which takes feedback about a particular product, and the feedback is in the string and we send it to a particular email. And now the email notification class extends the feedback notification class and implements and provides an implementation for the abstract method notify, right? Now, as we said, if we want to send SMS notifications as well, we can extend the feedback notification class. However, the issue here is that the notify method has a parameter called email, right? And that is not compatible with the derived class for derived class SMS notification, because instead of an email, we now require a mobile number, right? And hence the derived class method is not compatible with the base class method. And even in the main code, the email feedback notification method works fine because we are sending an email as a parameter. But for SMS notifications, the notify method will not work because we are sending a mobile number instead of an email. Now let's see how we can use the Liskov substitution principle here, right? So what we will do is, in the feedback notification abstract class, or the base class, we will not include the email parameter, but include the email parameter as a parameter which is specific to the email notification class. And here, as before, the email notification class extends feedback notification, and in the implementation of the notify method, we are just taking the parameters, the product and the feedback, right? And through the constructor of email notification, we are setting the email parameter. And here we are using that parameter in the notify method. Now similarly, this will work for SMS notifications as well, right? So in SMS notifications, we create specialized parameters called, let's say, mobile number and carrier, and we initialize this during the object construction time. And we can call the notify method, which just takes the parameters product and feedback. So in this example, we can see that the methods in the derived class can be substituted by the methods in the base class, right? They are substitutable. They can be interchanged without breaking the code or without causing any disruptions in the code. So this is an example of the Liskov substitution principle. And now in the main method, we can see that we create an email notification object, right? And we pass an email as a constructor field. Similarly, we create another object called SMS notification, which has parameters of the mobile number and the carrier, right? And the notify method is the same as that of the base class. In this way, we have refactored our code which did not follow the Liskov substitution principle into a code where the derived classes can be substituted by methods in the base class.